Hello, physical systems. So this is our first class lecture that's meant just for physical systems. All the other ones before now have been for my other classes as well, geology and earth science. But this one is especially for physical systems. This slide shows about physical properties. It also kind of talks about what physics is about in general. And we'll get this down to some nitty-gritty details today, and we'll get to do some math for the first time today. A lot of people freak out that this class has some math incorporated into it, but please don't. So science speaks two languages. It speaks the language of English, reading and writing, and speaks the language of math. So we need both to do science, and we'll see why when we finish the slideshow today. So this first slide is due now. If you think you can do the math to answer this question all the way, go ahead and do it. I'm not going to go through the math, but let's just go ahead and let me go ahead and read it, and I'm going to give you a chance that you could pause the video and try it on your own. So let's get started. Honey Bunches of Oats says that it contains 160 calories for every cup of cereal. Erica does not want to consume more than 100 calories for breakfast. If she only ate Honey Bunches, should she eat less than or more than a cup of cereal? And the challenge part of the question is how much should she eat? So I'm going to pause the video right there, and if you guys want to try to, anyway, just go ahead and take the time to pause it and figure it out on your own, and we'll be right back. All right, so this question says, if that Erica wants to consume or does not want to consume more than 100 calories. So her limit is 100 calories. Each cup contains 160 calories. So since 100 calories is less than the 160 calorie per cup limit, she should eat less than a cup of cereal. So this is just kind of a problem, and we use physics to understand it. You might not know that. The word calorie is a unit of energy. We'll be talking a lot about energy this term. So that's how we measure energy. We use seconds to measure time, feet to measure length. We're going to talk a lot about that in just a second. So to answer the question exactly how much cereal should she eat to meet her 100 calorie limit, so the answer is 0.625 cups, which I believe is 5/8 of a cup. I can't really show you the math of that right now, but if you want to go through that later, we certainly can. So, like I said, today is all about physical properties. Physical properties are basically the properties of the universe, how our universe works. You can almost think about this like pieces or rules of the universe. So before we get going, the class that you're enrolled in is physical systems, and the credit that you guys get is half of a science credit. So this class plus chemical systems make up the normal high school class physical science. Physical science is a whole high school credit. We decided to split the class into two different pieces: physical systems and chemical systems, just to make life a little bit easier for you guys, so you guys can learn everything as a part of a whole. So physical systems is the physics side of physical science. If that's confusing, don't worry about it. So this class deals with the study of physics. So what is physics? Physics is the line of study that aspires to answer the question, how does the universe work? So if you think of the universe as like one big machine, physics kind of describes the rules of the universe, the laws of the universe. You kind of think of it that way. In this class, we mainly study the interactions between matter and energy. Matter is like everything that we can touch. The air, I can wave my hands through it. I can feel the air around me. Liquids, solids, anything I can see and touch is matter. Energy is kind of what makes that energy move or give that matter some heat. So we'll be diving into matter and energy a lot this term. Let's talk about physical properties. How do we talk about matter and energy? Well, the three main ways we talk about matter is length, time, and mass. Every other physical property that we talk about is based off of one of those or a combination of those three physical properties. So let's talk about each one. So length. So length is, just simply put, you can kind of think of it, the distance between one point to another point. So I got one, there we go. 1 point over here, 1 point over there. Length is the distance between those 2 points. So if I have a length over here and length over here, well, now I can make a rectangle. I can make an area. If I have a length over here, and then length up here, then I can make a cube. I can measure a volume. Well, so we'll be talking about some of that later. So there's 2 units that you see on your screen for length. There's the SI unit, which for meter, imperial unit, yard. So before talk about those 2 units, SI unit stands for Standard International or International Standard. So back in the, I think, 19th century, European countries adopted something called the International Standard System of Units because everybody measured everything differently. Everybody's feet weren't the same. Everybody's yards weren't the same. Everybody's inches weren't the same. So they adopted, specifically for science, the SI system. And so that is the units that we'll be using in this class because these are scientific units and we're in a science class, so we want to learn what the scientific units are. Imperial units, those are simply units derived from the British Empire. And guess what? America uses imperial units because you know why? Because it was originally a British colony. But America, not even England, uses imperial units anymore. So why do we still use imperial units? I don't know. Everyone else uses SI units, but we use imperial units. Whatever. So the base unit for length, if you're a scientist, is a meter. A meter is a little bit more than a yard. And if you don't know what a yard is about 3 feet. So a meter is about 3 feet. I wish I had a meter stick with me, but that's about a meter. If you can see my screen. So that's length. Next basic property of physical property is time. The SI unit for time is seconds. And guess what? The imperial unit for time is seconds. So yes, when the SI system was invented, they just decided not to mess around with time because everybody was used to seconds, minutes, and hours, and they weren't going to try to make new units for that. So seconds is the unit that we use. That's our base unit for time. I think everybody should know what a second is. If not, you can just find a YouTube video for, say, how long is a second, and I'm sure tons of videos will show you. If you know what a second is, you can also just set a timer on your watch or your microwave oven. We use seconds every day. So length, time, and the last basic property, physical property, is mass. The SI unit for mass is a kilogram, and the imperial unit is a slug. Have you heard of a slug? No, you haven't. Okay, I mean, you've heard of the bug slugs. You've seen slugs, I'm sure, but so when we hear the word kilogram, then we think, oh, that's my weight. So mass and weight are different. To measure our weight, we use pounds. The SI unit for pounds is a newton. So those Newton, slugs, those words don't sound familiar. The reason you haven't heard of the word slug is because there really is no imperial unit for mass. When we measure ourselves on a bathroom scale, here in America, we use pounds. That is a measure of weight. When other countries measure themselves on a bathroom scale, they use kilograms, which is a unit of mass. So what's the difference between mass and weight? I'm so glad you asked. So it's important to know that mass and weight are not the same thing. We are usually talking about the same thing when we talk about mass and weight, but they're not really the same. The reason why kilograms and pounds might sound so similar, like 2 different ways of measuring the same thing, is because everything we measure is on the earth. What I want you guys to know is that I'll talk about that slide in a second. I want you guys to know that weight is a measure of the force of gravity. Mass is a measure of how much stuff something has. So how much stuff you have never changes. As long as you don't eat and don't go to the bathroom, how much stuff you have in your body never changes. Your weight can change depending on where you are in the universe. The thing is, most of us spend all of our lives on the Earth, so the way that gravity influences our body never changes because because we never leave the Earth. So let's talk about exactly what mass is again. So, since mass and weight aren't the same thing, let's talk about a little bit about what mass and weight are. So there are two ways to think about mass. You can either think of it as a measure of matter, like how much stuff something has. So, So I have a bottle of water and a cup of coffee. So this water has a lot more mass because it has a lot more stuff, has a lot more water. I'm not going to shake my coffee, but my coffee has some mass, but not as much mass because there's not as much stuff in it. There's not as much liquid. That's one way to look at matter. Another way to look at mass is a measure of inertia. Inertia is how hard it is to move something. It's much harder to lift my bottle of water because there's more liquid, but not as hard to move my cup of coffee because there's less liquid. So that's two different ways to look at mass. We'll address both of them, but I think the one on the left is easier. Mass is how much stuff something has. Here's another example to show you why mass and weight are not the same. So you have an astronaut. Again, let's assume he didn't eat anything or didn't go to the bathroom. Okay, so on the Earth, he weighs 1,200 newtons, but has a mass of 120 kilograms. Now, like I said, the stuff that he's made of does not change. So on the moon, he still has a mass of 120 kilograms, but his weight is significantly decreased. You've probably heard that if you go to the moon, you feel lighter or you have less weight, which is true. Your weight changes, but your mass does not change. The only reason his weight changes is because the gravity on the moon is much less intense. So you get a lower weight, but the same mass. So I hope that helps you understand what mass is. Mass is the stuff that has inside of you. It doesn't have to do with gravity. Gravity has to do with weight. So let's continue talking about physical properties for a second. I'm going to move my little camera over here for just a little bit. There are something. So the three basic properties that we went over are length, time, and mass. From those basic properties, we can combine them in lots of different ways to get to derived properties. So there's lots of derived properties. We're just going to go over three just as an example today: velocity, volume, and density. So that word velocity, if you haven't heard of it, is very similar to speed. We'll be talking about speed and velocity later this term. The SI unit for speed is meters per second. So if you go so many meters in 1 second, now we're talking about a velocity or a speed. Imperial unit for a velocity is something we're probably a lot more familiar with, miles per hour. If you can travel 70 miles an hour on parts of I-55. That's a unit of speed. We're talking about length per unit time, miles per hour, meters per second. We'll be talking about velocity later on. Today I want to focus on volume. Volume is the amount of space that something occupies. SI units for volume is a cubic meter, or quite simply a liter. If you buy a 2-liter bottle of soda, you know that, or versus a 1-liter bottle of soda, you know that the more liters you have, the more soda you have. Imperial units for volume are cubic feet, or sometimes the gallon, which is why I put the picture of the gallon of milk there, because we're used to seeing that. So when we see the words gallon and liter, we're not talking about weight anymore. We're not talking about mass either. We're talking about how much space something takes up. For example, my water bottle is currently sitting at about 550 milliliters, which that basically is half a liter. So if I had less water, it would be, less than half a liter. But I could just as easily have filled this up with air, or I could have filled this up with steel or chicken or whatever. I put anything in here. It's not, so the volume is not telling me how much something weighs or how tall something is. It's telling me how much space something is taking up. So I can use this cup to measure how much space any item is taking up in my water bottle. That's what volume is describing. Density, again, this is a combined measure of different things. Density is the amount of unit mass per unit volume. Okay, so now we talked about mass, how much stuff something has, versus volume, how much space something takes up. So those are two different concepts. Remember, mass is how much stuff something has. Volume is how much space something takes up. Just keep that in mind for a second. SI unit for density is kilograms per cubic meter, although we'll be using grams per milliliter in just a second. Imperial units, which again are completely irrelevant, there really are no imperial units for density, slugs per cubic feet. So take that for what it's worth. So to kind of emphasize what density is exactly, let's look at this example here. Which of these weighs more, a pound of feathers or a pound of iron? So which one do you think? So if you're reading this carefully and you know what we've been talking about so far, it's a trick question, right? A pound of feathers, a pound of iron, well, they both have the same weight. It's 1 pound. But this kind of addresses a deeper issue. Which one has the higher density? Which one has higher mass per unit volume? Well, it's the iron. Iron has higher density because iron can put a lot more stuff, a lot more atoms or molecules into a much smaller space. So it's very compact and dense. Whereas a pound of feathers, I had to get a lot of feathers before I get to a pound. And in fact, the picture you have in our slide is probably not even a pound of feathers. So here's the answer. They have the same weight, but the iron has much higher density, meaning that more weight occupies a smaller space. Or really, it should say more mass occupies a higher space. Who says that teachers can't make mistakes? Okay, so here's our equation for density. Yes, I said equation. We're going to do a little bit of math. Density equals mass divided by volume. Remember, density is the mass per unit volume, or just little d equals little m over big V. So let's do some math with calculating density. So we're going to use different units, grams per milliliter. So gram is a unit of mass. So just to give you an idea of how much a gram is, if you pick up a paper clip, that's about 1 gram. 1 gram of mass in your hand would be about a paper clip. A milliliter is a little bit less than a teaspoon. So that when we say grams per milliliter, take the mass of a paperclip and expand that to about a little bit less than a teaspoon. That's 1 gram per milliliter of density. So let's do some examples together. The next 3 slides have some examples, and I'm actually going to do those 3 examples in a different video because the format I'm using won't allow me to draw my screen. So look for the other video. There should be a link right next to this one, and I will see you there.